All right, Macy, let's read the top. In relation to theta.
In relation to theta, label the sides of the triangle below as opposite, adjacent, and hypotenuse.
Okay, so in relation to theta, we know our hypotenuse is the largest side. Opposite is when it jumps from theta, and then the remaining has to be the adjacent. So let's do a recall of SO, CA, and TOA. You're gonna have to write today more. I know. So we know sine is the ratio of opposite over hypotenuse, correct? Yes? And then we know cosine is ratio of adjacent over hypotenuse. And then tangent is a ratio of opposite over the adjacent. Now they have a reciprocal. So what that means is cosecant is reciprocal of sine. So if I were to write this out, let's leave the one as it is. Sine is basically opposite over hypotenuse. And if y'all remember back in Algebra 1 or even in this class, if I have a fraction over another fraction, we multiply by the reciprocal on the top and the bottom. So we have hypotenuse over the opposite, hypotenuse over the opposite. And what's going to happen on the bottom, they're all going to eliminate. Is that right? So we have opposites cancel each other out, hypotenuse cancel each other. So in the end, cosecant is simply hypotenuse over the opposite. Now, if you don't want to do all that and just do reciprocal of the sine, that's fine. Okay? So let's skip that piece on the next one. For cosine, reciprocal is secant. Instead of doing all that work, what can I simply say?
H over A.
H over A, very good. Hypotenuse over the adjacent. And then same with the tangent. If it is opposite over adjacent, cotangent must be adjacent over the opposite. So we're going to use this quite a bit for you to like naturally memorize in the end. Okay? Today it sounds awkward. So I'm going to repeat myself. Sine and cosecant are reciprocals. Cosine and secant are reciprocals. Tangent and cotangent are reciprocals. And something interesting fact. All the reciprocal has one co. Sine and cosecant. Cosine and secant, one co. Tangent and cotangent, one co. Okay? If that kind of helps you, cool. If it doesn't, let's find a different way. All right, we all remember 45, 45, 90, and 30, 60, 90. Today is the day I'm going to teach you what a radian mode is. And you don't need a calculator. Don't take it out. I'm going to show you what that means. Back when we did our trig, I had you guys go into mode and automatically change to degree mode, right? Now, radian is going to be our focus today. But we're not using a calculator because we have our brain. So here we go. Let's write out some reminder off to the side. Let's write out 45, 45, 90. Leave some room on the bottom. And then let's write out 30, 60, 90. And before we convert these to radian mode, I want to talk about something in general. If I give you a quadrant, the beginning is going to be 0 pi. And then I want you to also write something out. Anyone know what pi is equivalent to in degree mode? Oh. Okay, how about this? What if I tell you 2 pi is a full circle of 360? Then what can we say about 1 pi?
180.
180. So I'm going to go to 1 pi. From here to here, that's 180. That's 1 pi. And if I go all the way around, it's going to be 2 pi. What is half of 1 pi?
90.
Pi over 2. So if I have 0 pi, pi over 2, and that's 1 pi, what fractional value must go right here in between 1 and 2? 3 over 2 pi. 3 pi over 2. And if you're like, well, I'm not comfortable with that, that's okay, because we're going to go over the whole unit circle. And I think I have it on the back. Uh-oh. My unit circle is gone. Let me check. All right, so then given 1 pi is equal to 180, what do you think 45 degrees will be in relation to pi?
1/4 pi.
1/4 pi, so could we write pi over 4? Yep. So on 45, underneath, let's write out pi over 4. Then we have pi over 4. Then how many is 90 in radian? Pi over 2, half a pi, correct? And then let's go ahead and write our ratio that we did back in unit 6. 1 root 3 does not change, or 2 I mean. How can I represent 30 degrees in radian mode then? Pi over 6, because if pi is 180, 180 divided by 6 is 30. So then for 60, 180 divided by what? 3. And 90, 180 divided by 2. So if it's comfortable for you to look at pi and convert that to 180 as you're looking at it, it might be helpful. Because again, this is kind of new to us. Okay? And our ratio is 1, root 3, and 2. So, Macy, pass this out. We're going to fill in the unit circle together. There you go. That might be enough. Maybe you need more. Okay, when you get your unit circle, go ahead and write your name on there. In the front, it's going to say degree. The back is going to say radian. And we may have enough time just to fill that part out today. We'll see how far we get. And the degree is the easier part. So let's start with the degree mode. Okay, on our degree mode, I want you all to write out, this is 0 degree. And when I go full circle, that is also 360. And if I go halfway, that's going to be 180. Between 0 and 180 is going to be 90 degrees. What degree measure will be on the bottom then? 270. So I'm going to start by counting by 45s. Thank you. So when I count by 45s, that's exactly in the midpoint between 0 and 90. So that's 45 right here. So I have 45, 90. If I add another 45, that's one how many? 135. And if I add 45, we get to 180, correct? Let's add 45 again to 180. 225. And then if I add 45, we get to 270. Those are our check marks. Add another 45, we get 3 how many? 15. And another check mark is going to be 360, correct. So let your quadrantals or the axes be a checking point. Are we good with that one? Now let's do the 30s. But from here, I know we have 30. Then I have 60. Is that a good self-check? 90? And then from 90, we have 120, 150. Oh, why did I put a little extra 0? And then self-check would be 180. Is that correct? Okay. And then after 180, we get 210. And 2 how many? 240. Is that a self-check? 270. Bless you. And then to 300. To 330. And do I have a self-check? Good. So have we marked pretty much all around the circle so far?
Yes.
Yep. So that part is no problem. Now let's go on to our radian mode. I think I'm going to use this. Okay, on our radian mode, I want you to keep this paper out so we can look at it with this number right here. Okay? So on the radian, let's start with the 0 pi. So here's my 0 pi, which is also 2 pi, because 2 pi is 360. Halfway between that will be 1 pi. And we know 90 degrees is pi over 2. I wish I can like zoom out of this, but I can't. And that's 3 pi over 2. So let's do what we did a while ago. The 45s. How do I represent 45? Pi over 4. So this is going to be pi over 4. And if I go again, this is technically 2 pi over 4. Is 2 pi over 4 same thing as pi over 2? Yes, it is. Again, self-check. So let's add another pi. 3 pi over 4. And then on here, we have 4 pi over 4. Isn't 4 pi over 4 really in the end 1 pi? So again, self-check. Let's go to our third quadrant. If I add one more pi, we get 5 pi over 4. And then we have 6 pi over 4. Is 6 pi over 4 same thing as 3 pi over 2? Self-check again. And then I have 7 pi over 4. And then I have 8 pi over 4. Is 8 over 4 really 2? Yes, it is. So we're good with that one. Now let's do our 30 degrees. What was 30 degrees represented in radian? Pi over 6. So let's go to pi over 6 here. Pi over 6. My next 30 degrees is 2 pi over 6. If it bothers you that it's not simplified, you may write out 1 pi over 3. Okay? I'm okay with this. So we have pi over 6, 2 pi over 6. Here I have 3 pi over 6. Is 3 pi over 6 same thing as pi over 2? Yes, it is. Then I have 4 pi over 6, 5 pi over 6. Then I have 6 pi over 6. Is 6 pi over 6 same thing as 1 pi? Very good. 7 pi over 6. Are we basically adding 1 to the numerator, basically? 8 pi over 6. Here I have 9 pi over 6. Is 9 pi over 6 same thing as 3 pi over 2? Yes, it is. Then I have 10 pi over 6, 11 pi over 6. Here's our self-check. 12 pi over 6. Is that the same thing as 2 pi? Very good. All right. So are we okay with what we have so far? Just adding 1 to the numerator each time and self-checking. So let's go on to our packet. And I'm going to give you one example. Maybe 2. I'll give you 2 examples. Okay, let's circle number 1 and 4. Number 1 and number 4. And as we find the answer, we're going to transfer them into the unit circle. Okay, on number 1, which trig function are we using? Sine. And 30 degrees. Is my 30 degrees in which quadrant? I think they're all in quadrant 1, right? I think this whole thing is on quadrant 1, but we'll see. So here's my 30 degrees. And let's think about our ratio. Opposite of 30 was 1. Hypotenuse was what? 2. And we know this one is going to be 460 degrees, meaning this has to be radical how many?
3.
Radical 3. So let's write out. Sine of 30 is opposite over hypotenuse. And our opposite of this one, when I jump from 30 degrees, is 1. Hypotenuse is 2. Is this anything new? No, it's not. Okay? So there's one thing that I have to mention on the unit circle. And I know I'm jumping back and forth. Sorry about that. Okay, on our unit circle, let's go ahead and write out our quadrants. 1, 2, 3, 4. And if y'all remember, the quadrant 1 is always positive. Is that true? What about quadrant 2? Negative, positive. Quadrant 3? Negative, negative. Quadrant 4? Positive, negative. So then let's add on to something about quadrantals. There's something that's going to happen on the axes. If I go to the right one, we have 0. As in, when I say unit circle, 1 unit circle, so 1 comma 0, what would the coordinate be up here? 0 comma 1. What would the coordinate be on this side?
-1, 0.
-1, 0. On the bottom? 0, -1. So an interesting fact about our, unit circle is the following that I want you to write off to the side. Your x comma y is really converted to the following. Whatever's on your x value is your cosine. Whatever's on your y value is your sine. Which also means cosine goes left to right, meaning it's an adjacent movement. Sine goes up and down. That's going to be our opposite movement. What's up? How's that? So let's see why that matters. On number 1, did we find sine of 30 is equal to 1/2? Okay, so here's how we actually form it, or fill it in. On 30 degrees, give me an order pair.
5, 7.
Sine is our y value, correct? So on our y value, I'm going to put in 1/2. There's something else I can do. Go to 150. Isn't 150 and 130 lined up, meaning it's got the same y value? Would you agree on that? So can I copy 1/2 to the y value of that one? Yes, I can. But there's more. Go down to 210. On my 210, my y value has been reflected over the x-axis. So we know our y value really indeed is negative 1/2. Is there another spot I can go on to that lines up? 330. At 330, what is my y value? Negative 1/2. And if you're like, well, how do I know it's negative? Look at your quadrants. Y is positive here, y is positive here, y is negative, and that's what I pretty much mimicked. So when you know one number, do you know 3 other numbers basically? Yes, we basically do. So then I want you to now look at number 4. On number 4, we're looking for the angle at what number? 0. So let's go ahead and go to 0 and put a dot. And we know at that axis, or if it hits on the x or y axis, it's going to be one of the ones with the 1 and 0. 1 comma 0. And by the way, in pre-cal, these are called the quadrantal angles. But if you don't remember, that's okay. Now cosecant. At cosecant of 0, what is the ratio of cosecant? Go back to the front. H over O?
A. O.
It's H over O?
It's the opposite of sine.
And let's write OP as an opposite. It looks like it could be a 0. In a quadrantal, hypotenuse is always 1. Always 1. So we should add that on here. In a quadrantal, hypotenuse is always 1. I know it's a lot of information. So then, our opposite. Opposite is a y movement, correct? What is a y coordinate right here? 0. 1 over 0. Can we compute that?
No.
It is undefined. And because it is undefined, we can't do anything with a unit circle, unlike on sine of 30. Okay?